Good afternoon. This is a Titan sample return from the Caltech Space Challenge 2022. With us today is Colby Phillips, Fabian Martinez, Francisco Garcia, Ivan Sanchez, Devin Boyd, and myself, Stephen Perzo. Next slide. For the outline, we have the mission overview, introduction, modeling assumptions, technical calculations and analysis, final design, and the summary. Next slide.
So for our mission overview, the objective is to return a sample of surface liquid from Titan, as well as take the in situ measurements and detailed analysis of the samples collected. Some concepts that we will be using will be the use of a planet sphere of influence, as well as their gravity assist trajectories. Some key results that we found were that in trajectory 1, the delta V was 26.54 kilometers per second. For trajectory 2, the delta V was 29.78 kilometers per second, and for trajectory 3, the delta V was 48.12 kilometers per second. Next slide, please. So recently, NASA's Cassini spacecraft has revealed large seas of liquid methane on Titan, which is one of Saturn's moon, which this is in relation to the discovery of extraterrestrial life or characteristics that can sustain life within our solar system, which is highly desired. And this leads to the current mission to gather samples from Titan's liquid lakes on its surface. And lastly, some software that we'll be using will be Malto, MATLAB, NASA Ames Trajectory Browser, as well as NASA Horizon Database.
Here are some given assumptions that we'll be using for our challenge. We have the sample data return date from Titan at December 2045. The infinity at Earth's sphere of influence, return trajectory at less than 12 kilometers per second. Max power of the nuclear electrical propulsion at 20 kilowatts. Can't speak today. Dry spacecraft mass at 1,200 kilograms and an electric propulsion ISP of 10,000 seconds. Here are some constraints that we'll be using for our model. We have the Saturn's radius at 58,232 kilometers, Titan's radius at 2,574.7 kilometers, Titan's orbit radius around Saturn at 1,221,870 kilometers, and Titan's gravitational parameter of 8,978 kilometers cubed per second squared. And here are the equations we'll be using for our modeling. We have the gravity of Titan and velocity at Titan insertion, height of Titan, the infinity, total change of velocity, and the final mass. And we have the equations written on the right.
All right, so going into a little bit of our technical calculations and analysis for our trajectories. We observed our various trajectories plotted for the Titan transfer, with the return date being before 2045. Trajectories were direct missions to Saturn and then to Titan. Pork chop plots were used to obtain our original arrival and departure dates to Saturn in order to give an optimal delta V value. These pork chop plots can be seen on the right and bottom, with the bottom ones being the ones we generated in MATLAB and the right ones being the ones that are generated using the web resource. Here are some of the key values that we found in order to figure out which trajectory was going to be optimal for us. It is important to note that our delta V for the final leg to Titan had to be calculated using MATLAB and the MATLAB code shown in the end slide. Trajectory 1 provided a delta V of 26.54 kilometers per second, the propellant mass used being 4,110 kilograms, mission time being 2,971 days. Trajectory 2 provided a total delta V of 29.78 kilometers per second, with a propellant mass used of 4,951 kilograms, with our mission time being 2,991 days. Trajectory 3 gave us a total delta V that was way higher than the others, being 48.12 kilometers per second, and our propellant mass used for that leg was 6,603 kilograms, with our mission time being as well extremely higher, 5,662 days. At the bottom are the plots for all three of these trajectories that we generated using Malto. With obviously the last leg not being shown in the plot because we had to do hand calculations for that leg due to Malto's incapabilities to account for Saturn's gravity for the Titan transfer. The launch vehicle that was chosen was narrowed down to one of these four: Delta 4 Heavy, Atlas 5551, Atlas 5501, and the Atlas 5521. This graph on the right compares those and a little bit more options in order to give us a rough guess as to which launch vehicle would be optimal for our C3 value.
In this slide, we see the final design. So as you can see, the optimal trajectory that we chose was trajectory 1, having a total delta V of 26.54 kilometers per second, an impact velocity of 0.0571 kilometers per second, a propellant mass used of 4,110 kilograms, a mission time of 2,171 days, and the launch vehicle used for this trajectory was Delta 4 Heavy with an ISP of 462 seconds. Also, the low thrust propulsion system used was a nuclear electric propulsion with a specific impulse of 10,000 seconds. And the chemical propulsion system used had an ISP of 430 seconds. In the left-hand side, we again see the reiteration of the plotting payload and C3. And it backs our decision on why we chose the Delta 4 as our launch vehicle used. Also on the right, we see the plotted trajectory 1 with all the legs composing the full trajectory in detail. Next slide, please. For the final design timeline, this is backing up the best trajectory we choose, which is the Earth launch on May 24th, 2030, with the launch T3 of 26.6 kilometers squared over second squared. We arrive at Saturn on May 14th, 2035, with a full time of flight of 1,817 days. And our Titan arrival and insertion would be on May 16, 2035, with a time of flight of 1,819 days, with a full duration of 28 days in Titan. We depart Titan on June 13, 2035, after a total time of flight of 1,847 days. Finally, to complete the mission, we have an Earth arrival on July 12, 2038, with a time of flight of 2,971 days, which successfully completes our mission. Next slide.
In summary, we were able to complete all of the mission requirements and return our sample and all science data to Earth by December 2045. We did this by using MATLAB and Malto to create pork chop plots and do the mission design as well. Next slide. This is our appendix that includes the MATLAB code for that last leg from the orbit around Saturn to Titan. Next slide. And here are some of our references. Thank you so much for your time.